Today's lesson is about dilations. So the key little topic that a lot of people think about for dilate is if you have your eye and you go to the eye doctor, sometimes they'll look at your eye and look at your pupil. And sometimes they'll do some kind of little chemical agent in your eye or blow some air into it or look into your eye. A lot of times they want to look into your pupil. Sometimes they will dilate your eye and make your pupil much larger so they can see into your eye easier. That's an example of a dilation. So it's whenever your pupil starts small and it ends up getting a lot larger, but it stays the same shape. This is an example of a dilation. Another little picture example would be this little triangle dilates to that triangle. So to do that, you could multiply by a scale factor. We've talked about scale factors before. So scalar multiplication, multiplying by a scalar value. So whenever we've done our architecture project, we'd multiply by units like 3/16 or 9/16. That's an example of a scale factor, an example of scalar multiplication. So k equals some number. That's the key little fact. The key thing you need to remember is if the scale factor is less than 1, but still greater than 0, what's going to happen? If your scale factor is less than 1 but greater than 0, and you multiply by it, what happens? Yeah, so that's called a reduction. It's going to reduce the size of your original shape. I don't have an example of a reduction over here, but basically it would be like taking the shape and putting it over here instead. So if you started off with a big shape and then you got smaller, that's an example of a reduction. What are my values for an enlargement, though? Y'all remember those values? Greater than 1 is an enlargement. Any values greater than 1, when you multiply them, it's going to make the figure bigger. Just think about your height. If you take your height and you multiply by 2, what happens? You double your height. So that's a good little example. There's one other little formula I want to give you, and I'll show you how it applies to example 1. Sometimes we're going to use this little formula right here. It's k equals CP prime over CP. So it's basically saying you can find your scale factor if you measure from the center to P prime and measure from the center to regular P. That will give you your scale factor. So we're going to apply that to part A over here. So let's go find, what is the distance from C to P prime on this shape over here? Well, C to P prime. Oh, where's P prime? I can't see the prime. Can you see it on your paper? It's the bottom one. Okay, so how far is that distance? 10. So that's 10 on top. We're solving for our scale factor. And the value on the bottom, it only wants you to go to regular P. That's only a 6. Does anybody know what that simplifies to? Yeah, good job. 5/3. Now you need to think to yourself, is that an enlargement or a reduction? Well, if you divide, 5 divided by 3, is that going to be bigger than 1 or less than 1? That's bigger than 1. So since k is greater than 1, we have an enlargement. Good job. Same kind of process can be done for part B. We need the C to P prime first. Do you see where the P prime is? I think it's this one. There's that little prime. So how far is it from C to P prime this time? 11. And then C to the regular P, 22. That's 1/2. Is that scale factor greater than 1? No, it's less than 1. What do we learn about less than 1? When scale factor is less than 1, we have a reduction. Those are two really, really good problems. try this little checkpoint real quick. See what you can do on that one. So on this little example, you need to remember your little formula. Sometimes writing it out will help you remember it. So K equals CP prime over CP. So the prime goes on top. Real quick, let's find, oh, there's CP prime, that's 4. And the regular letters go on bottom. 4 over 20 simplifies to 1/5. So our scale factor is 1/5. Is that a reduction or enlargement? Okay, so since it's less than 1, greater than 0, we have a reduction. Up next, we're going to do this little problem. It says, draw and label parallelogram LMNP, then construct a dilation with the scale factor of 1/2. The other key thing you have to remember is they're wanting you to use that point L as the center of dilation. So I'm going to bring up a blank page and kind of show you this process. So if you have this little shape, is it drawn like that kind of? That's not very good. Let's try that again. I'll make it prettier. All right, so that's a little bit better. Is M over here? All right, M, N, P. And L is that center of dilation. So let's think. If we have a scale factor of 1/2, we need to think about what it means to multiply by 1/2. Well, what's going to happen if you multiply your height by half? You're going to be half the size. You're going to be half the size. So basically, we're going to be creating a shape that is half the size as this original. So this is actually a pretty easy idea. So if you have a ruler, which I don't think it's really needed a whole lot on here, you need to think about your distances. So what you need to do, you need to measure your distance from L to M. You need to measure your distance from L to N. LP is also needed. There are 3 distances that you would need to measure. I'll measure mine on the board, and you can just kind of think about the math a little bit. I'm using a ruler right now, and I got LM is 17 centimeters on my big board. LN is 25 centimeters. And LP is 11 centimeters. Now this is the process. So go ahead and write those numbers down so you remember this process. So the process, first off, think about your scale factor. Is it going to make it bigger or smaller? This is going to be a reduction. And then we made our measurements from the center to each of the other important points. Up next, we need to think about what happens when you multiply by 1/2. Well, yeah, it cuts the number in half. So we're going to do our new little prime letters down here. Our little prime letters are going to be LM prime, LN prime, and LP prime. So these are our new little segment lengths. And all you need to do is take that 17 and multiply by 1/2. Does anybody know what that is? 8.5. Take the 25, the original measurement, and multiply by 1/2. What do you get? 12.5. Good. And the last one's 11. You take 11, you multiply by your scale factor. This is scalar multiplication, and you get 5.5. So these are the new distances I need to measure. So what I do is I line my ruler up along LM, and that's along the line for my new M prime, except I don't need to measure 17 anymore. I just need to measure over 8.5. So measuring along LM, I only need 8.5 now, which is right here. That's my new M prime. I'm going to do LP next. So LP, it was 11 centimeters, which is right here. But now I only need to measure 5.5 in that direction. So along LP, I only need to go 5.5. So that's right there. There's my new P prime. Now the last one is maybe the most challenging, but it's not a big stretch. This isn't that difficult. So I did measure LN earlier to be 25. So L all the way to N was 25. But I don't need 25 anymore. I just need to measure 12.5 centimeters in that direction. So visualize this. I'll make a dotted line. This was my measurement earlier. However, it's changed now. It isn't going this whole 25 centimeters. I'm only measuring how much along this line? Half of it, which is now 12.5. And 12.5 is about right here. That's my new N prime. So I still measured along that same line, but I stopped halfway. Now, you can see these 3 points. I just need my L. Where's my new L going to be? Same spot, because that's where my center is. It actually is very easy. So you can see the prime shape. That's my new shape. That's my image. And you can see my original shape, which is called my pre-image. So the red shape is my pre-image, and the blue shape is my image. On the test, you're going to have a problem like this. Maybe it'll be a small scale factor. Maybe it'll be a big scale factor. Maybe if I say this is now your center and your scale factor is 5, you need to think about how you would do this. So what you would need to do is have the points labeled. You would measure from P to A, P to B, and P to C. And you would get those numbers. So maybe P to A is, we'll say 10, P to B is 13, and P to C is, it looks like about 10 also. What would you need to do to those numbers? Multiply by 5. So your new numbers are going to be PA prime is 50, PB prime is going to be, they may know that in their head? 65, that's PB prime, and PC prime is going to be another 50. So I'm just making up numbers. So what you need to do is think about this. Along this line, which was 10 originally, I now need to keep going in that direction. How far? 50. So I can kind of, there's 1, there's 2, there's 3, there's 4, there's 5. So I just estimated real quick. That's where my new point would be. Obviously, the bigger the number, the larger your picture will be. Along PB, I need to reproduce this measurement again. 5 times the length. So the new length is going to be 65. So it's going to be way out here off my page. PC prime is going to be along this, way down here off the page. So be able to reproduce that. The cool thing is, if you extend all these out, you can actually create a number of different pictures that are the same. So watch this. I'll create another one over here. If this was your A prime, your B double prime, and your C double prime, how do you think I'd figure out the scale factor? Okay, so I could go P to A, and we already have that, it's 10. Oh, PA double prime. So maybe if that was R50, and you measure P to A, and say, actually that's not going to be 50, that's only going to be about double. So 20. PA prime would be 10. How would you find your scale factor? 20 over 10. What's our scale factor there? 2. So you can do a lot of different things with these pictures, and they kind of end up being really cool. So we've now skipped a few problems. They dealt with matrices. We're not doing matrices, so those can be skipped. We're now on example 5. It says, the vertices of a triangle are given. Find the image after the composition. So remember, when we're doing these compositions, I want to see every little part of the composition. So if you did 2 other transformations, I want to see those as well. So first thing you need to do is go ahead and graph this triangle. Take a little time and graph that triangle. After you've graphed that triangle, you need to go down here and you need to look at this little translation form. You got to remember, what does it mean to do x plus 4? Yeah, that means right 4. So real quick, we need to write down right 4. What does y plus 2 mean? Up 2. So I need to move this shape right 4 and up 2. And I need to make sure to label properly. That's L prime, M prime, and N prime. The last thing I need to do is do this dilation. It says the dilation is centered at the origin. I'll do this in a different color. Centered at the origin. So I'd put a big dot on the origin. That's my center of dilation. And it says I need to do a scale factor of 2. I need to multiply everything by a scale factor of 2. So there's a number of different ways you can do this. You can measure. Not always the fastest when you have a graph. A lot of times they'll give you this kind of problem on ACT, so you're not going to have a ruler there. So you can kind of think logically about this. One way is to write down these coordinates. So let's write them down real quick. L prime is what? 2, 3. M prime is 3, 1. And N prime is 1, 2. Well, usually what do we do with scale factors? We multiply by scale factors. So that means I can multiply all these numbers by 2 and I can get my new points. One little change, it's not N prime, it's K prime right there. So it's not N prime, it's K prime. So multiply every number by 2 to get your double prime shape. So I'll write that down real quick. L double prime, multiply by 2, what do we get? 4, 6. M double prime, we get 6, 2. And K double prime, we get 2, 4. Now if you graph those, you're done. So this measurement should work for anybody. However, some people are really visually minded, so that means they can probably figure out another way to do this. In my opinion, when it's a low scale factor that's nice and clean like that, I would be thinking about little patterns. So I see this going up 2, right 1. To double it, I just do that again, up 2, right 1, and I land on K double prime. For the M prime, that's right 3, up 1. I do it again, and I get my doubled coordinates. I get the new position. So that kind of process could be done as well, but this math over here is great. That shows you your answer really easily. Try out checkpoint number 5. This one doesn't give you a graph, so it's more like what you'll see on ACT. So on this little checkpoint, it gives you the vertices RST. It wants R prime, S prime, and T prime after a scale factor of 2. We see that one a lot because it's easy to do the mental math. What do we do on this one? Multiply everything by 2. So R prime is going to be -8, 6. S prime is going to be -2, -4. And T prime is going to be 4, 2. Very simple. Very simple. That's all we're going to do today.